Oh, a couple more of these, and then I'll give you some to try on your own. Let's do the derivative with respect to x of, we got negative 4, that's a cube root of x squared. Negative 4 times the cube root of x squared plus 8x squared minus x plus 2. So negative 4 cube root of x squared plus 8x squared minus x plus 2. And perhaps a rewrite is in order here. We got radicals and math. So that's like saying the derivative with respect to x of, I don't mind the negative 4 coefficient, but I'm going to call this thing x to the what power? 2/3. Yeah, 2/3 power, right. The exponent forms the numerator of your fraction. The root forms the denominator of your fraction. So 2/3 would be the fraction that results. Plus, this rest of it's fine. 8x squared, the minus x, the plus 2, that's all good. It's just that first term that needed a little work. So let's differentiate this term by term. I no longer need derivative with respect to x because I'm actually taking the derivative. So I'm going to stop writing derivative. It's being done. The negative 4, that can stay. The 2/3 comes down with it, and what do we get?
Negative 1/3.
What's that?
Negative 1/3.
Negative 8.
Oh, sorry.
Yeah, try it. Yeah, negative 8/3, right? This is 4 over 1. So you have 2 over 3 being multiplied with it, 8/3, negative 8/3. Oh, you were saying the exponent.
Yes.
I got it. Now I'm with you. Now I'm with you. Negative 1/3 would be the power. 2/3 take 1 away, puts you in a 1/3 deficit. Plus 8x squared becomes 16x minus. Derivative of x is really 1. Yeah, there's a 1 coefficient here. First power. So the 1 coefficient stays, the 1 comes down and gets multiplied, there's still 1. And then x to the 0 is just 1. And then the derivative of 2?
0.
Ah, it's that old constant thing again, right? This is actually, well, this is fine. I guess you could also write it, we could clean up that negative exponent.
This should be acceptable.
I'll probably have you clean it up for the assignment, just so you get the practice of moving back and forth. We'd have a negative 8 in the numerator. We'd have a 3 in the denominator. And with it, what would we have, what? Yeah, 1/3 power means cube root. Negative means now it's in the denominator. So we have a cube root of x in the denominator. And the rest of it, just copy paste. All right, one more. For after the app.
You volunteered. You could sit at the top of this.
We want to find the equation of the line tangent to f of x equals 1/2 x to the 4th minus 2x cubed plus 4 when x equals 2. Find the equation of the line tangent to f of x equals 1/2 x to the 4th minus 2x cubed plus 4 when x equals 2.
Really?
Really?
I don't know, I guess I do that.
So our answer is going to be what kind of answer here? Slope intercept form, yeah. Y equals mx plus b. That's how you write the equation of a line. That's at least how you can write the equation of a line. So of these 1, 2, 3, 4 things that we don't know, maybe, or of these 4 things we need to know, how many do we actually know right now?
1.
One of them for sure. We know what x is. So they tell you x is 2. So we're going to plug that in for x. The second thing we can find is pretty quick. You just have, what else can we find and how do we find it?
The slope.
Plug in. B.
Y
The
0
slope.
x y
Okay.
0.
Wow. All right. I heard one idea. I might have heard it more than once.
Y 0.
Can't you find the slope?
We can. We're going there after this. Yeah. For now, we can find the y value. The y value comes from f of x. The slope will come from,
Plugging in. Plugging in.
yeah,
The slope will
Plugging
be
in
from the
f
from f prime.
derivative.
Okay. Y values come from f of x. Slopes come from f prime of x. Ooh, right? All right, so we'll start with the y value because we've already got f of x. So y is just f of 2. If you plug 2 back in here, send that to the 4th power, you're at what? 16. Cut it in half, and it's 8. 2 to the 3rd power, 8 times -2 would be -16, okay, plus 4.
12.
-4? All right,
Negative.
we've got our x, we've got a y value. We're going to get what next? M, the slope.
Why did the name slow down?
It was in honor of Hanson back in the 90s. You know the song Mbop? For a while it was Slope out of the reverence for Hanson. And then they kind of went out of style for a while, and then the tradition stays, but now it just confuses everyone. Either that or whatever language the person who came up with the abbreviation for spoke, maybe the word for slope started with that. That's just my theory. I'm not being sarcastic. I don't know either. That's my theory.
Okay.
All right. I was sarcastic about the Hanson thing.
Oh, I thought maybe.
Okay. Slope. Slope comes from the derivative when x is 2. Okay. So let's get.
You're gonna do some editing.
Yeah. So let's get f prime so that we can plug 2 in and get the slope. F prime, if you bring down the 4, your first term becomes 2, and then x to the 3rd, 2x cubed. bring it down, then drop. Yeah, okay. I see what you're doing. Minus 6x squared. And the plus 4 becomes a plus 0. So I'm not even going to bother with that differentiating the constant term.
Now I put it in 2.
Plug in 2.
Can you plug it in?
If it were 4x, the derivative would be 4. If it's just a constant, though, that was that first property we talked about.
Oh.
It's just, its derivative is 0.
Oh, yeah.
Is everyone okay with where this came from? Stork frog.
Yep.
F prime of 2, if you cube the 2, 8, double that, 16, good. 2 squared, it's 4 times 6 would be 24. So negative 8 would be our slope at that point. But that's all we care about is the slope at that point. Let's put it all back in. We already know that y is negative 4. We found that out already. M, we found is negative 8. The slope is the derivative at that point. For x, we're using 2. That was given to us in the problem. We just have to figure out b. This is negative 16. If you add 16 to both sides, you get 12. All right, so we know our slope, we know our y-intercept, we know our m, and we know our b. So we should be able to write the equation. Y equals, yep, negative 8x, and then plus 12 at the end. And that's what we're looking for. Okay. We all right on all that? Okay. So we got assignment. I was going to start over at 1, but let's just keep on going. Let's call it 11, right? That's where we left off.